Okay, everyone. So now we are learning the union. To understand the union, I am taking an example here. Let us suppose that we have declared one variable c that is of integer type. We know that here we can store the integer value. Let's say the value is 101. Now, afterward we have declared one more variable which is, let's say, g, that is of character type. We know that it can store the character value. So these are the independent variable. But let us suppose that I want to create a data type where the integer and character both should be combined together, means it can store integer and character. So for that, I will take both of them into bracket and apply the union. So we are having the union. With the help of that, we can have multiple data types and we can store their value. After the union, we can provide their name. Let's say here I am providing the name that is employee. So we can say that union is a user-defined data type. And inside the union, we can have different type of data, just like we are having one integer and one character. That means with the help of union, we can store a record. Record means, let's say we are having is the employee ID, which is 101, and employee grade. So this is how we can store different types of data inside the union. So we can say that union is the collection of different data types, just like we are having the int and char. So they both are combined or grouped together under a single name. So here employee is the union. So with the help of employee, we can have two data type. One is the integer and second one is the character. So union contain different data type, and with the help of that, we can store the record. Means we can store integer as well as character, both things together. And here it is totally depending upon the user that which should be the data type that are the part of union, because here inside the union we are having one integer and second one is character. So it is depending upon the user which data type to take. So that's why it is called user defined data type. We know that user defined data type and collection of data types grouped together under a single name. These two features are there into structure also. Let us suppose in the same way, if I provide, let's say int c, so where I am representing that int, this is an integer type which contain c for the code. Now then afterward we are having is a char, which is data type which is having g, variable that is grade. These two data type, if I am grouping together, now here I am writing the struct. We know that struct keyword is used for defining the structure. Let's say here the name I am providing is employee. So we know that there we are defining the structure and afterward semicolon. So here also semicolon. So in both the cases, in structure and union, we are having the user defined data type as well as they are the collection of different data types with the single name. In the structure also, different data types are there, int and char, and single name which is employee. So we can say that structure and union both are same. So union is same as the structure. So here we can say that union is having the same syntax as structure. So here if we are having the union, we simply define the union by saying union employee. Then afterward we are going to provide the data types and variable name, then data type and variable name, then afterward bracket close and semicolon. Similarly, if we are using the structure, we will provide the keyword that is struct, then the name of structure, then afterward data type int and the variable name, then data type char and the variable name. So both syntax is same. If both are user defined data type, both are having the same syntax, both contain different data types inside that, then why we need this union? Because there is a huge difference between structure and union. So now we are understanding how the structure and union are declaring their memory. To understand the difference between union and structure, first of all we are taking the structure. Now here inside the structure, we are assuming that our memory is of 1 byte. Means in the memory, we are having the 1 byte blocks. So first of all, when the structure is defined, we are having is integer. So int C, we know that int contain 2 byte. That means inside the memory, we are taking the 2 byte of space. So let's assume that this is our memory where we are having all the blocks of 1 byte. So 1 byte and 1 byte. Let's say we are having the address which is 301, then 302. So here we are assuming that there is 1 byte. When we are talking about the integer, we know that integer is of 2 byte. That means the complete 2 bytes are taken by the integer. So here, starting from first block till the end block. So here, this is consumed by the integer. So here we are assuming that these 2 blocks are reserved, and here we can store the integer value. Now afterward, inside the structure, we are having is the char G. So here is the character. We know that character take 1 byte. That means 1 block or 1 byte will be reserved into the memory. So we know that every block we are assuming is of 1 byte. So here in this case, let's say the address is 303. Now here we are using the char, means character, and character is taking 1 byte. That means the 1 byte space is reserved, and that is for the character. So we can see that there are individual blocks. That means if I talk about the first 2 byte, that first 2 byte belong to integer. And next 1 byte, that belong to character. So every variable inside the structure is having individual memory. You understand that we are having 2 data type. One is integer and second one is character. They are having individual memory. You assume that there are 2 people and they 2 are having separate rooms. Separate rooms, they can change it, they can modify it. So other person is not affecting. Whenever one person is changing something, other person is not affecting. That is the same case with the structure. In the structure, both data types, just like integer and character, they are having different memory spaces. In this memory location, they are changing their value, they can modify it. Other value is not affecting. Other person or data type is not affecting. So that is the structure. In the structure, the size of structure is equal to sum of the sizes of its elements. We know that in the structure we are having 2 elements. One is the integer, and integer is of 2 byte. So here 2, and character is of 1 byte plus 1. So here 2 plus 1 is 3. That means structure size is of 3 byte. So here whenever the structure is defined and it is going to store its variable, at that time it will consume 3 byte, means individual memory. So here this structure is of 3 byte. Now we are learning the union. If we talk about the union, we know that in the same manner we are having 2 elements. The first element is the integer, and integer take 2 byte. And the second element is character, and character take 1 byte. In the union, it is totally different from the structure. In the union, we don't have the individual memory. We are having the shared memory. That's why the size of the largest element is the size of union. So here we know that out of 2 and 1, which is largest? So here 2 is the largest. That means the size of union is only 2 bytes. So if we talk about the union, then how it will take the memory? So first of all, we know that we are having is the first element, which is the int C. And int C is having 2 byte. So here 2 byte means it will take the 2 byte of the memory. We are assuming that our memory is of 1 byte. So here we assume that the address is 301 and the second address is 302. So here if we talk about the integer int C, which is having the 2 bytes, that means starting from 301 until 302, we are having the integer. So here we have reserved 2 blocks which are of 1 byte, and here we have stored the integer element. The next element we are having is the char g. That means the char g is having the 1 byte. This 1 byte is not extra byte. This is not individual memory. In the union we are having is the shared memory. So no new memory will be reserved. It will be the same memory which we have started. Inside that memory we are going to take that block, and here we are going to store the character. That means already if some element is there, that element memory will be taken. So what that mean? The value which we have previously stored, that will be corrupted or lost. So if you are going to store the integer first, then you can print it, no problem. Then after you are storing the character, then integer value will be changed, because you are consuming 1 byte of the integer. Then integer value you have saved will not be the same, but the character value you have updated will be the same. So means union, you can access one element at a time. You cannot have the individual memory. In the union we are having is the shared memory. So here we are having the next point about the union, that union is having the shared memory. So here in the union we can see that if we are using the integer, then we are consuming the 2 byte, and if we are using the character, then out of that 2 byte again we are taking the 1 byte. That means individual memory is not there. So we can say that in the structure the members are having their individual memory, but in the union they don't have the individual memory. All the members use same memory location. Because in the union all the members are sharing the same memory, means shared memory, then there is a problem. The problem is that, let us suppose that there are 2 people and they both want to sit at same place. So they cannot do anything with that place, means they cannot modify its value. Let's say if I am coming and I am storing something in one room, other person is coming, that is changing that room. Again if I am coming, I am changing it. Again that is coming, that person is changing. So that is not possible. Means if one person is doing something, that will not be reflected later on. So in that case, let us suppose that first of all we are having is the integer. So we are storing the integer. Later on the character is coming, character is changing it. So integer value is corrupted or lost. So here we are having only one possibility, that at a time only one person can work. That means only one member can work at a time in the union. So union handle only one member at a time. Or in the other words, we can say that in the union we can access the member whose value is currently stored. In the union, if we have stored the integer, we can access it. But later on, if we are using the character and we are storing it, then integer value is lost. So here the latest is the character. So in the union we can access the member whose value is currently stored, means we can access the character, because integer value is already corrupted or the lost, because we are having is the shared memory. So here we have learned that union is the user defined data type, because inside the union what are the members, integer and character, that is totally depending upon the user which data type to take. So here in the same way we are having is a structure. So structure is also the user defined data type, which is having the members based upon the user. Union is the collection of different data types grouped together with the single name. So here in the union we are having int and char, they are combined with the name, that is employee. Same with the structure, we are having the int and char, different data types with the same name, that is employee. Union and structure both are having the same syntax. So here union and structure both work in the same way in terms of syntax. But union use the shared memory. So here inside the union, whatever the maximum size of the element, so here 2 byte is the maximum. So 2 byte of the memory is reserved. But in the structure, we are having is the sum of size. So here 2 and 1, their sum. So here that is the 3 byte of the size. So inside the structure we are having is the individual memory, and inside the union we are having is the shared memory. So in the structure every element can be stored at the individual memory, but in the union we are having is the shared memory. Because of the shared memory, Inside the union, we can handle only one member at a time and we can access the latest element value. Because once I am storing the first element and I am again storing second element is updating the value of first. Why? Because the memory is shared. But in the structure, there is no as such problem because their memory is the different. Individual memory is there, both can modify, both can update, so nothing is affected to the other element. So now we are learning that how to define union. For defining the union, we are having is the syntax. The syntax of union is same as the structure. So here only one difference is that we are using the keyword which is union. So here first of all we are using the keyword which is union. Then afterward we are providing the name of the union. So we are assuming that the name of union we are using is the employee. Afterward, the body of the definition, so here bracket start, we are having is the type. Let's say the first type we are using is the integer. So this is an integer type. Variable 1, let's say the integer we are using C for the code. Then afterward type, let's say we are using the type which is character. So we are using the char. Then the variable 2, let's say we are using the G. So here two variables are taken and the body is closed, then semicolon. So this is called the definition or defining the union. Now here union, so there this union is the keyword. Then we are having is the employee. Employee can be tag or the name of union. Inside the body we are having int C and char G. These are called the members or the elements. And this complete thing is called the definition of the union. This is acting like a template. Template means whenever we are making the variable of this union, at that time this complete thing will be followed. The next thing we are discussing is the declaration or declaring the union variable. For declaring the union variable, we are having is the syntax. Whenever we are dealing with the system defined data type, let's say we are saying int and its variable we are creating, we know that we simply say A. So int is a data type which is system defined and A is the name of variable. In the similar manner, union is the user defined data type. That's why here we are writing the complete thing which is union employee. So here union employee is acting like integer. Just like integer is the system defined, union employee, this complete is the user defined. So here we are writing the complete union name. So we are writing here union and we know that the name we have taken is employee. So this complete is acting like a user defined data type and its variable we are creating, let's say A. So here we are creating the variable A. Whenever we create the normal variable, we know that one block of memory is reserved and that block is named as A. And here let the address is 301. Similarly, when we are declaring the variable of union, at that time the memory is reserved. We know that in the union there is a shared memory and that is the size of the largest element. So inside the union we are having the first element which is integer and integer is having 2 byte. Second element we are having is the character and character is having 1 byte. So here we can see that out of 2 and 1, 2 is the largest. So here the size of this union is of 2 byte. That means this union will consume 2 byte of memory. So here variable A, that variable is going to consume the 2 byte of memory. And let's assume that the address is 301 and 302. Variable A is having 2 byte of the memory and inside the variable A we are having 2 members because we know that variable A is of union employee and the employee is having 2 members and the first member is int C. So here we are having is the C. So C will take the complete 2 byte of the memory because integer is of 2 byte. And we are having is the next member which is char G. G is of character type. That means this G will take 1 byte of the memory because character is of 1 byte. And here memory is shared. Next thing we are having is the initialization, means initializing the values to union elements. Let us suppose that we are declaring the variable of the union. So we are writing here union, then afterward the name, that is employee. So we know that this complete is acting like a user defined data type, and here we are making the variable, let's say A. So this whole part is called the declaration. And afterward we are providing the value, so we are putting the equal to, then curly brackets start. Now here we know that there are two members of the union. So the first member is of integer type. So here we are using, let's say 101, and second member is of character type. Let's say I am providing A here. Now what is going to happen in that case? So whenever we are providing the first value, which is 101, that is of integer type, and we know that it is having the 2 bytes. So here 101 will consume the 2 bytes, means complete 2 blocks, 1 byte will be taken, and here 101 is stored successfully. Now afterward we are storing A, and we know that A value is the character, which is of variable G and which is of 1 byte. Now the previous value, so here 1 block will be updated. Now what is the problem? Whenever we are updating the first block, then the previous value will be wrong. That means 101, which was the previous value we have saved, that will be corrupted. So if you are going to print the G, that will be perfectly fine, proper answer will come. But if you are printing the C, proper answer will not come because the value is corrupted. So this is not the way of initializing the union. We have to go step by step. So we have to access members one by one and provide them their values and display them. For accessing the union members, first of all, we are having the syntax. We know that if we are going to initialize both members together, then the current member value will be taken. Just like first of all we have saved 101, then afterward we have saved A. Because of the shared memory, previous member value was corrupted or it was the wrong value. So here 101 value will be corrupted, means wrong value, only A value will be persist. So the latest member value will persist because of the shared memory. But here we are accessing one by one. Now we are providing the individual values. So here first of all we are saying that union variable, we know that the union variable is A. So we are taking that A, then dot, so dot is applied, then the member, we know that the first member we are having is C. So that C member we are taking, and the value we are providing is 101. We know that the member C, this is of integer type, that means it consumes 2 bytes. So here 101 value will be taking, and in the shared memory we have consumed the complete 2 bytes. So here 2 bytes are completely consumed. Immediately after that we should print that value, means if you are printing that value by saying printf, then afterward it is integer value, so %d, then comma. To access this value we will write variable name A dot C. So by this on the user screen we are having the value as the answer. So here answer will be 101. So here 101 output will come. Now again for the second element we are using the same thing. We are saying the union variable. We know that the variable we are having is A. So A dot, then member, we know that the second member is G. So that G member is taken, and we know that this is of character type. So here the character value we have provided, which is A. We know that G is a variable of character type and character take only 1 byte. So here we are having A. When the A will come inside the memory and it is a shared memory, so it is going to consume the 1 byte. That means 1 byte will be taken by the character. Now the previous block was updated. When the block is updated, the previous value got corrupted. Now, this corrupted value we are not going to access because we have already displayed it. So nothing affecting us because we have already displayed it. So once the new value is coming, the previous value 101 is corrupted, means that value got changed. But that effect is not coming to us because the value we have already printed. Now afterward we are using the printf statement, and in the printf we know that this is the character value, so %c for the character. Then afterward we are having is the variable which is a dot member, and we know that the member is g. So here afterward we are going to provide the semicolon. So by using this printf statement we are going to display. So here we are displaying the second value which is a. So here we have learned that when we are dealing with the union, we has to go with all the members one by one, their initializing and display, then initialize and display. So here first we have initialized the C, then displayed it. So here 101 was there. Then we have initialized the G. Then the previous value of C got corrupted. We cannot access the same value. So now afterward we are going to display the value of G, and we are having the value which is A. So one by one we are going to access the union members. Now we are taking one real life program. With the help of that we will understand that how union work. Now we are learning the program of union. So first of all we are having is the comment that union, compiler will not read this because this is a comment. Then hash include, which is the preprocessive directive, which is including the header file stdio.h, which is for the printf and scanf functions. Then afterward we are having is the void, means no return type, main, this is a driving function. Inside that we are having is the keyword union, means we are going to define the union, and the name of union is employee. So here starting from the bracket till the end, this is the body of the union. Inside the body of union we are having is the first element which is int code. Then afterward we are having is the char grade. So this complete thing is called the definition or defining the union. Now after that you are having the user defined data type which is available, that is union employee. So this is the complete data type which is user defined. Just like we are having the system defined data type int, and its variable we declare just like a. In the similar manner, union employee is the complete user defined data type, and here a is the variable. So here we have created the variable, or we have declared the union variable. So this is called declaration or declaring the union variable. When we are declaring the normal variable which is int a, at that time one memory block is reserved, and let's say the name is a and that is of let's say 301 address. Now in the similar manner, whenever we are creating or declaring the variable of union which is a, in the similar manner the memory is reserved. We know that inside the union we are having two elements. The first element is integer which is having of 2 byte, and second element is character which is of 1 byte. And we know that union work with the shared memory. So the largest element size which is 2. So here the complete union that is of 2 byte means size of the largest element. So that memory is reserved. So corresponding to A we are having is the memory. Now we are assuming that the memory is 1 byte, means each block is of 1 byte. And inside this variable A we are having is the first element which is integer. So here integer which is code. So that code will be having the complete 2 bytes of the memory because code is of integer type. So here whenever code we will assign, at that time 2 block of memory means 2 byte of memory will be taken. Next element inside the variable A is the character. So here we are having is character grade. Character consume only 1 byte, so here it will access the first byte. Here we can see that both the elements are sharing the single memory, which is of 2 bytes. So here we have created the variable A, and this variable is of union employee, and employee is having 2 elements, code and grade. So there code and grade, these 2 elements are accessing the shared memory, and shared memory is declared, that is of size of maximum element, which is 2 byte. So here 2 byte of memory is reserved, and this is the shared memory. Now afterward we are having is the initialization. In the union we are initializing the elements one by one. Just like in the normal variable, we provide the value, let's say A is equal to 1 and the value is stored. In the similar manner, inside the union, which is the user defined data type, we are going to take the values and put them into the elements. So here to access that, first of all we are taking the variable name A. So here A is the variable which is of union, then dot code. So with the help of the variable, we are going to access the code. So here this code we are accessing. So here 101 value we are providing. We know that this is of integer type. So here this will take the complete 2 bytes. So 2 bytes will be taken by the code, and which is 101. After that, we are going to display its value. So we are saying printf means printing on the screen, %d for the integer value, it will take the value from a dot code. So here the value is coming to %d. So a is the variable and code. So from their code and its value 101 we are taking and displaying. So 101 we are displaying. Now afterward we are going to initialize the second member. So here a, this is the variable. Then afterward dot grade. So here the second element we are accessing, which is grade, and that grade value we are providing, which is A. So here A value we are providing to the grade. Because they are using the shared memory, that's why the 1 byte, we know that character take 1 byte, so 1 byte will be taken. So out of the previous initialized 101, we have taken 1 byte. So the previous value was corrupted. That means 101 value is no more there. That value is either lost or corrupted. Now afterward we are printing the value. So printing on the screen, printf, then %c for the character value, a dot grade. So a is the variable, and from that we are taking the grade. So a dot grade, the value is a. So that value a will be displayed on the screen. So this value is taken and gone to the %c and displayed on the screen. So here the previous value is lost. This is a simple program of union. Now I'm going to modify this program and see how the output will come. Afterward I am adding one more line. So this line is printf means printing on the screen /n for the new line. So here cursor is into the next line. Now afterward %d for the integer value. So a dot code, we know that a is the variable of union, and from that we are accessing the code. We know that code value is already updated. That means the value will be either corrupted or lost. So here the value will be coming and we are displaying it, and we can see that when we are displaying the value, this is 65. This is not the correct value. The correct value was 101, but that value is lost. Why? Because it's the shared memory and we have already updated with the a. So here the value was updated. Now afterward we are using %c, which is for the character, and a dot grade. So here a is the variable, then grade we are accessing, and the grade value we know that is a. So here that value will come and will be displayed. We can see that the latest value is correct. Why the latest value is correct? Because we have updated with the latest value. So when we have updated the value, the latest value we can access inside the union. The previous value will be lost. So that is all about the union.